So I was hoping I'd have the circuit boards back by now, but I didn't actually submit them until, well, a little bit later than I expected. So instead, I just kind of wanted to give a little bit of an update because right now they're stating that they're about 78% done. So routing packaging should be ready to go. And so hopefully by the end of this week, I'll have my new circuit boards. So I'm just going to kind of go over a digital version of what we had, and I'll switch these to 3D. So the left is the original design, just starting off, a few of the things that kind of retained, still using an NRF52 module, but it's a different module because I have lots of stock of these guys. QFN motor controller is now I think a SOP or a TSOP style package, and there's a little bit of a reason for that. A lot of this was 0805. I'm sticking with 0805s, a few 0603s, but I can put 0805s on those in a pinch. Fix some wiring with this guy, but I maintained this same Molex connector, which is the same kind that's internal, but there's a couple of catches or a couple of forward-thinking elements there. So let's just quickly switch over and just get some dimensions so that I can make sure that I'm locking onto the same layers. So the original was 16 by 45 millimeters, and I hate that. And the new one is strangely 16 millimeters, but by 30. So we're 2/3 the length. However, what's really interesting is I actually have an older design that I redid after that original one. I never made this one. 14 by 25. So I made it smaller, but there's a couple of things here I don't like because one, I have a pick and place machine. I can do 0402s. It's a pain. Like, unless I'm doing a bunch of them, it's almost not worth it. So placing all of these would for a handful of boards would be very painful. It just would not be great. A lot of the same parts. The only difference is this is bigger. I could have made it smaller if I would delete the connector. Switch back to the board view. Deleting the connector would have netted me about there, 6 millimeters, and switching to a QFN and 02 instead of 0805 components here. Wrong layer, so I can't select them. All of these components, well, that would have been probably easy enough to get down, but honestly, 30 millimeters, a little bit bigger than a quarter. And switch back here. I like the 3D view, but yeah, so I still have a lot of the same things. There's a lot of overlap here, poorly spaced out. Programming is painful. I can't use the programmer clip of my design. Do still have the connector, but I put it on the back. And I sort of have connectors on the back, but you'll notice that there's very little. And there's a lot more test points. So this is actually the optional interface for if you want to not use the wireless aspect of this module, you can plug in directly. So, I mean, in reality, you would save yourself 50 milliseconds to 50 to 100 milliseconds potentially by using a wired interface. Not only that, I mean, the Nordic chip is so reconfigurable, and I've created, if we go around back here, don't move things, and we turned off a few of those layers. What do we got? We have power, ground, and 4 buttons. Well, you know what 4 wires directly to the microcontroller can do? I could create an SPI interface. I could create an I2C and a UART interface. I could create, some, I believe, Hold on, let's go check. Because I you know what, I bet I wasn't as clever as I would have liked. So we've got button 1, 2, 3, and 4. So they're all digital, so we don't have any analog ones. That's a little sad. And only one of my test points. You know, just kind of where it cropped up for where things landed and where I could actually fit this, because this was an afterthought. Oh God, mistakes were made. So, however, you'll notice that this connector here, slightly different than this one, but I can actually mount that connector, the new style connector, to this. So we'll get to these in a second, but so this is the original connector, and you'll know 6 circuits loaded. Yeah, that's fine. Electrical current maximum per contact. We know that those motors can do 3 from the previous video. Now these guys, it's more about density. So yeah, so while these are rated continuously for 1 amp, you can go more than that for a bit. Is their contact resistance? These are rated for 1 continuous. These are rated for, depends on your current density, for up to 2 or 3 continuous. This has kind of a jank locking mechanism. This actually has a little thumb plug. So not super great for waterproofing. Down the road, I could take this, use this connector here. The footprints match up. They actually use a smaller footprint. This here, the 3D model isn't great. Is this Born's connector here, and it has a 30 milliohm max, but it too, it is limited to a 3 amp continuous rating. So this is a good. I was trying to get to a 5, but even with larger contacts, yeah, I couldn't do it. And this is so even going up to a pitch of 4, which would be as wide as the board. I've made this so that the pads go horizontally, so you slide the battery in from the side. So depending on which configuration, if we do that chainstay configuration or the on derailleur mount, the batteries will slide in from the side. And I think that may have some advantages given the historic issues that SRAM had with their battery clip. So if we can avoid having to use a lock clip like that, then it should make this easier to work with. But let's get to why is this so big. So I think in the last video I actually said I was going to use a DRV88. So I'd said the 8876, and actually they're the same data sheet. You can see like none of the text is changing. You can see something in here, but basically they're the exact same chip, except one has 200 milliohm resistance and one has 700 milliohm resistance, and that's a big change. So if we want to have that derailleur have the maximum potential current possible, that's why I wanted to have very low resistance ability to change that connector. So I wanted the battery path in through here to be as big as possible. I've got some huge vias in through here into the motor controller directly out, and another 700 milliohms, almost an ohm. Yeah, that's not great. So have to switch to they call it an HT-SOP 8874. Now we know our motor can't really draw more than 3.5 amps, but if we wanted to use this to drive something differently, then we have the ability. So if we want to make just a wireless motor controller, a DC servo style thing, that gives me the ability to do that. So that's great for future projects, and I can power a bigger motor. Now, right, I2C. So we're not doing any battery dividers or anything. Center pins are used for I2C communication to the battery, and that all comes back to a protection board over here that has those giant FETs and can do current measurement across this, in and out, battery balancing, and multiple temperature sensors if needed, and it's generally single-sided. So we'll make an adapter board for this side. And you noticed that alert pin, I didn't bother with it. VCCE, that was for this EEPROM here that turns out I didn't need because of that whole, there was already standards and this chip already takes care of everything. So that's good. Otherwise, I think that's everything. It's pretty basic. your 32 kilohertz oscillator. That's your PFET for the Hall effect sensors to control them on and off. Motor driver that, like I said, we can do lots of amps. Slide in battery contact to the side. Oh, and for people who know me, they'll know that I found some cool methods of getting like clip artwork and doing the outlines and stuff. But when I have a board this small, I can only get a tiny piece of artwork on it. I like to try and hide artwork under things. So there's a little bit of a little tiny cutesy wolf doing and a woo to complement the one that's sitting there smiling nicely. And the other thing I did this time was, these are my general layout for my programming lines, because I ground clock data for your SWD IO and SWD clock. Power that can go in or out, so that's a little manual, and I usually have a UART on it for debugging. I broke out the reset line. It can be useful, but I barely ever use it. 2 test points, those are spares. And then I broke out most of the motor stuff. So the sine and cosine from the motor are there. The current, because there's an analog output for the current, the Hall effect enable, and these are all the motor controller stuff. So I can, and I probably will, just populate this main chip here and a few of the auxiliary stuff, and I'll probably plug it into some dev boards initially to get up and going. Don't usually remember what these is. Oh, mode. Mode, not fault, phase, not sleep, and motor enable, and the phase and what I'm calling phase and motor enable are also depends on your mode. So if you set certain modes. Oh yeah, also has a neat feature that I can set, these resistors are wrong, but you can set a value, and if your motor and that'll correspond to a motor current, and if it goes over that, you can set your modes for what happens. Yeah, I wasn't seeing a lot of voltage sag. These values need to be tuned for the filtering coming in. And oh yeah, Kepler little accelerometer. It has most of the interface there, but I probably use an I2C mode, and it'll probably just be set to alert on move. I've almost never needed this pull down resistor and some pull-ups for the I2C. Button interface, just so that you can see the 4 buttons and the power and ground, so that you can power an external sensor after the regulator. And pretty happy with this guy as a power converter, or DC to DC step down converter. So hopefully end of this week I will get these, and then over the weekend I shall populate the first one, and yeah, hopefully some better news. Yeah, not all these videos can show real progress. I mean, this still took a while. I basically had to do this several times, so hopefully you find that useful. I had debated doing this whole thing in KiCad, and to make it fully open source. I might consider down the road when I have some free time porting it, but right now it's all done Altium, because generally that's what I use on a daily basis. So thanks for watching.